Welcome back for another deep dive. And today we're going to be tackling something that I think a lot of people might find pretty basic at first, but we're going to go deep and hopefully find some really interesting stuff. We're going to be looking at measurement and motion.
I love it. Yeah.
And you've sent in a textbook excerpt, and it seems to be geared towards introducing these concepts to maybe like middle school or high school students. But I think it's a great starting point for us to kind of springboard into all kinds of different directions. What do you think?
Yeah, absolutely. I think you're right. Most people think that they understand these ideas,
Hmm.
but when you really start to dig into them, it can really shift how you see the world.
Yeah, totally. And this excerpt, it starts off with this great scene where you have these two students, Pahili and Bucho.
Yeah,
They're arguing about desk space.
I love it.
And they're trying to measure it out using all kinds of random objects. It's so funny because haven't we all been there, like trying to figure out how big something is without having a ruler handy?
Oh, totally. Like using your hands or your feet or whatever's around. It just highlights how important it is to have standardized units, which the textbook goes on to talk about. Can you imagine trying to build something like a skyscraper using units like cubits or hand spans?
Yeah, those were actual units of measurement mentioned in the text. It's crazy to think about how people used to do things. So resourceful. But yeah, I can only imagine the confusion.
Oh, absolutely.
Mhm.
Chaos. Yeah. And that's exactly why the metric system and standard units like meters are so important. They brought this order to science and to global communication. I mean, think about it. Trying to collaborate on huge international projects would be impossible without this shared language of measurement.
Totally. And the textbook also goes into this really interesting history of transportation. It starts off, believe it or not, with walking. Just walking and carrying goods from one place to another.
It's a good reminder that humans have always had this need to get around, to explore. Even the very first boats, which were probably just hollowed out logs, I mean, that speaks volumes about our desire to push boundaries.
Then, boom, the invention of the wheel. What a game changer. We're no longer limited to carrying stuff on our backs. It's kind of crazy when you think about how one invention changed everything.
Yeah. I mean, the wheel, along with the domestication of animals, really set the stage for trade and for exploration and the spreading of ideas across continents. And get this, the textbook actually mentions how those early boat designs were inspired by fish,
Yeah.
like the shape of fish.
Oh, wow. So they were like doing biomimicry way back then. That's fascinating. And then, of course, we have the steam engine, which kind of kicks off a whole new era of transportation.
Totally.
Yeah.
And it just creates this domino effect, right? You've got trains going across continents, ships going faster than ever before. And this increase in speed, it didn't just change how we moved, it changed the whole world.
Yeah, think about it. In a relatively short amount of time, we went from walking to launching ourselves into space. It's pretty remarkable. And all these advancements, they really reflect our evolving understanding of motion, don't you think? From harnessing animal power to understanding air pressure to literally breaking free from gravity.
Totally. Absolutely. And each new invention came with these new challenges in terms of measuring speed and efficiency and safety. And those challenges forced us to get better and better at understanding motion.
That's a good point. It's like this constant feedback loop. And the textbook, it ties all of this back to the concept of measuring distances, which I think is a really interesting link.
It makes total sense though, right? As our ways of getting around got more complex, so did our need to measure things accurately.
Hmm.
Think about navigating by the stars versus using GPS to get around. It's a whole different ballgame.
Totally. And speaking of accuracy, the textbook gets into the nitty-gritty of how to actually measure properly. And they even point out the problem of a broken ruler, which honestly, who hasn't run into that at some point?
Right. And it highlights how taking accurate measurements can be tricky. You have to be adaptable and able to problem solve. Sometimes your tools aren't perfect. And that's true for scientists and engineers, really anyone working with measurements.
Absolutely. That's a good reminder that even these simple things are more complicated than we might think. And the textbook, it lays out how the meter is like this base unit, centimeters for smaller stuff, kilometers for big distances. It all builds so logically.
Yeah, and it's not just about convenience. It's crucial for science, for being able to share information. If every scientist in the world was using their own made-up units, can you imagine the chaos? The metric system is this universal language. It allows for real accuracy, and that's what leads to new discoveries.
Right. So we've talked about measuring in straight lines, but the text, it goes beyond that. It starts talking about different types of motion, and they have this cool activity where students track an ant's path. Yeah, and it's like this really clever way of showing that motion isn't just about speed, it's about changes in position over time. I mean, think about it. An ant might be slow, but it's constantly changing direction, covering ground.
Exactly. And then the textbook dives into these three main types of motion:
Hmm.
rectilinear, circular, and periodic motion.
Right.
So rectilinear motion, that's kind of what we usually think of when we think about motion, just something moving in a straight line, like a car driving on a straight road or a ball rolling across the floor.
Yeah, exactly. It's all about that linear path.
Then there's circular motion,
Mm-hmm.
and that involves movement that's a fixed distance from a central point. So like a Ferris wheel, or a planet orbiting a star, or even just the blades of a fan spinning around.
Exactly. And then we have periodic motion,
Yeah.
which is any motion that repeats in a regular pattern. So like the pendulum on a grandfather clock or the earth going around the sun, even our own heartbeats. That's periodic motion. Pretty cool, huh?
I know, I'm starting to see these different types of motion everywhere now. Like it's like the world is suddenly choreographed. Yeah, it
Yeah.
really is. Once you start noticing it, you can't unsee it. It's like motion is everywhere, even in things that seem perfectly still. Like that table over there. I mean, it looks solid, but really it's made up of all these tiny particles that are constantly vibrating with energy.
Whoa. Okay, you're blowing my mind a little bit. So much for solid ground, huh?
Right. And this actually leads into a really important concept that the textbook touches on: the idea that motion is relative. So something that looks still from one point of view could be a whirlwind of activity from another.
It's like how we think of ourselves as sitting here perfectly still, but from the perspective of, say, someone on the moon, we're actually hurtling through space on this spinning planet.
Exactly. It all
Yeah.
depends on your frame of reference.
Hmm.
And this isn't just like a thought experiment or whatever. It's fundamental to how we understand things like gravity, planetary motion, even the behavior of light.
The textbook actually does a good job of explaining this. They talk about how an object in a moving train looks different to someone standing on the platform. It's all about perspective.
It is. And that's a great example. And that actually brings us to another point that the textbook makes. Motion isn't always simple. A lot of times it involves different types of motion all happening at the same time.
Like a spinning top, right?
Yeah.
It's rotating on its axis, but
Yeah.
it's also moving across the table, so it's doing two things at once.
Exactly. Or think about a basketball being dribbled. It's bouncing up and down, which is periodic motion, but it's also moving forward, which is rectilinear.
Yeah.
It's wild.
I know. I'm starting to feel like a motion detective, looking for clues everywhere I go.
Uh-huh. I love it. And as you keep exploring this, you'll see that understanding these different types of motion, it's not just about putting things in to neat little boxes. It's about getting a deeper understanding of how things work at every level, from the smallest atom to the biggest star.
Yeah. The text ends on this really beautiful note. They talk about how we live in this world of constant motion. You know, everything from a snail crawling along to the moon orbiting the earth, even the blood flowing through our veins. It's all motion.
Yeah. And it's a good reminder that motion is what makes life possible, really. It drives our weather patterns, shapes our landscapes, allows us to interact with the world around us. It's pretty profound when you think about it.
I know. This deep dive is really making me think about the interconnectedness of everything. It's like we're not just observers of motion, we're active participants in this giant cosmic dance.
Beautifully said.
Yeah.
And it's that awareness, that curiosity about how things move and why, that drives scientific discovery. That's what helps us understand the universe.
You know, I have to admit, when we started this deep dive, I was thinking measurement and motion, kind of basic, right?
Hmm.
But now I'm seeing it with fresh eyes. It's like a whole new dimension has opened up.
That's the amazing thing about learning. It takes what we thought we knew and shows us all these hidden depths and connections. It's like magic. Even with the most basic ideas, there's always more to discover.
I'm definitely going to be looking at the world differently after this.
That's great to hear, because that's what we hope for with these deep dives, to inspire you to keep asking questions, keep learning, keep exploring, and always be curious about the world around you.
Absolutely. So for our listeners who are feeling inspired to learn more about measurement and motion, what would you recommend? Where should they go from here?
Well, first of all, I would just say, pay attention. Look around you. See if you can spot examples of those different types of motion that we talked about: rectilinear, circular, periodic. Look for those combinations of motions. It's all around you.
That's a great starting point. It's all about tuning into those details that we often miss.
And then don't be afraid to experiment. Take some everyday objects and see if you can recreate those types of motion. Build a pendulum, spin a top, get hands-on. See what you can learn about speed, direction, the forces involved.
Love it. Turning everyday objects into science experiments.
Exactly. And as you're doing that, ask yourself questions. Why does this ball roll this way? What affects the swing of the pendulum? That curiosity is what drives scientific thinking.
So true. And what about resources? Any books or websites you'd recommend for people who want to dive deeper?
Oh, absolutely. There are tons of great resources out there. If you want a fun, engaging introduction to physics concepts, I always recommend 6 Easy Pieces by Richard Feynman. It's a classic.
Oh, yeah, Feynman's great. His lectures are legendary. What about something more visual?
If you're a visual learner, there are some fantastic YouTube channels that break down complex physics ideas in a really easy-to-understand way. Channels like Veritasium, Minute Physics, 3 Blue, 1 Brown, they're all great. Lots of animations and visuals to really make those concepts click.
You know, one thing that I really loved about this textbook excerpt was how it brought these concepts down to earth. Literally, I mean, who knew that measuring a disk could be a gateway to understanding how planets move?
Right. It's a good reminder that science is everywhere. It's not just something you learn in school, it's in everything. The way a ball bounces, the way a tree sways in the wind, even the way your coffee cools down.
I think that's what makes this deep dive so fascinating. It takes these simple ideas and shows us how they connect to the bigger picture. We started with a textbook for students, but we ended up talking about relativity, the nature of motion, the vastness of space.
Exactly. And it just shows that learning is a journey. And the more you learn, the more you realize how much more there is to learn. It's kind of amazing.
This deep dive has definitely made me more curious. I'm going to be looking at the world with new eyes, noticing all the different types of motion, questioning how we measure things, just appreciating how everything is connected.
That's fantastic. That's what we love to hear. Because at the end of the day, the goal of these deep dives is to encourage lifelong learning, to spark that curiosity and give you the tools to go out and explore the world with a sense of wonder.
I think that's the perfect note to end on. We've covered so much ground today, from ancient units of measurement to mind-blowing ideas about relative motion. Who knows what other fascinating topics we'll uncover in future deep dives?
The possibilities are endless. So to everyone listening, thank you for joining us on this journey. Keep exploring, keep questioning, and most importantly, keep that curiosity alive.
Until next time, keep on learning.
There are so many. For a really good intro to physics, I always recommend 6 Easy Pieces by Richard Feynman. It's a classic for a reason.
Yeah, Feynman. I love Feynman. His lectures are the best. What about something a little more visual, like if somebody's a visual learner?
Oh yeah, if you like to learn by seeing things, there are some really great YouTube channels out there. They break down complicated physics ideas in a really easy to understand way. Channels like Veritasium, Minute Physics, 3 Blue, 1 Brown, those are all fantastic. They use animations and visuals to help you really get it.
You know, one thing that really struck me in this excerpt was how it took these concepts and brought them down to earth. Literally. I mean, who knew that measuring a disk could help you understand how planets move?
Right. It just shows you that science is all around us. It's not just something you learn in a textbook or in a lab. It's in everything. The way a ball bounces, the way a tree moves in the wind, even the way your coffee cools down.
I think that's what makes this deep dive so interesting. It starts with these simple ideas and shows us how they fit into the bigger picture. We started with a textbook for students and ended up talking about relativity, the nature of motion, the vastness of space.
It really shows that learning is a journey, not a destination. The more we learn, the more we realize there's so much more out there to discover.
I'm definitely feeling a renewed sense of curiosity. I'm going to be looking at the world differently, noticing all the different types of motion, thinking about how we measure things, and just appreciating how everything is connected.
That's wonderful to hear. That's what we hope for with these deep dives, to inspire that kind of lifelong learning, to give you the tools to explore the world and keep that sense of wonder.
Well said. I think we've covered a lot of ground today, from ancient units of measurement to those mind-blowing ideas about relative motion. Who knows what other amazing topics we'll explore in future deep dives?
The possibilities are endless. So to everyone listening, thanks for joining us. Keep exploring, keep asking those questions, and keep that curiosity alive.
Until next time, keep on learning.